So we're going to start this lesson by learning a new measurement for an angle. Up till now, you've dealt mainly with degrees. We're going to learn now what a radian is, and then its relationship between what a radian is and what a degree is. So I am going to first do a little survey here. Shami, how tall are you? 5'11", 5'10". Ben, how tall are you? Okay. Let's see here. Ramsey, how tall are you? 5'10". Ju Young, how tall are you? You haven't measured? Oh, man. Nikki, how tall are you? 5'3". Man, I'm trying very hard to get something here, but it's not happening yet. We'll try a couple more. Carmela, how tall are you? 5'1". Okay. Agape, how tall are you? Okay, it's not working. It's not working whatsoever. Usually, I'm asking around, and there's going to be somebody in class who doesn't know their height in feet and inches and only knows their height in centimeters. Is there anybody? Okay. So I try to find out if I can find someone who knows it only in centimeters, and then we have a whole discussion how, you know, if you're 177, you must be a giant compared to Shemi, who's only 5 something, and it's like, right? But the idea here is one is a measurement in feet and inches, and the other is in centimeters. And so you have to know how they compare to each other in order to work with them, because a centimeter is not the same as a foot. And so we're going to learn about radians, what a radian is, and how it compares to a degree, because 1 radian isn't the same as 1 degree. Okay? If I got you to jump up in the air and turn 180 degrees, you have an idea what that looks like, right? Yeah. Okay? If I got you to jump up in the air and turn 180 radians, do you have an idea what that would look like? Okay? Maybe some of you have heard of a radian before, so you have a kind of an idea. Some of you haven't, you have like, no, like, I don't know what that means. But 180 radians, if you turned that many times in the air, what would that look like? You would, okay, you would die. You know, you'd have to spin about between 25 and 30 times in the air. Just kind of crazy. So what is a radian? Well, first of all, we're going to draw a circle. So I'm going to draw a circle. I'm going to use this triangle for the radius here. So that would be, there we go. Now, this is my radian learning tool. It is a triangle. Does anyone know what kind? It's a special one, not just because I made it. It's an equilateral triangle. So when I draw, if I would draw that triangle on here, wow, that's another circle. It would look like that, roughly. And all of those angles would be the same size, so they'd all be 60 degrees. Now, the definition of 1 radian, and what makes radians used more in higher level mathematics and in university, is that the radian is connected to the circle. It means something. A degree, someone just picked 360 and decided to break it up into 360. Someone else said, oh, I don't like 360 because it's not a nice number. What if we made 400 degrees in the circle? And then a right angle is 100 degrees. Okay? You know what that's called? Those are called gradients. So there's a whole bunch of different measurement angles that we could do. We're most comfortable with degrees, but the radian, instead of being an arbitrary measurement, a radian is connected to the circle. 1 radian is when the arc length, so whenever this length along here is equal to the radius along here. So our equilateral triangle can help us see that. Can you see that if I start with my equilateral triangle here, I would have to bend it until the curve of the outside matched with the edge of the circle. But when I bend it by pushing down, what happens to this little angle here? This angle here gets a little bit smaller. So we can give now an estimate for a radian. 1 radian is a little bit less than 60 degrees. Does that make sense? 1 radian is going to be a little bit less than 60 degrees. Now you guys are taking pre-calculus math, which is pretty, like you can't even round early, everything's pretty exact. If you wrote a little bit less than 60 degrees as your test mark, you know, sort of like vague answers, solve for x, I think it's somewhere between 2 and 7. You know, those kind of answers, you know you want to be more exact. So how are we going to be more exact? Well, we're going to start by trying to figure out how many radians in a whole circle. So now that we know what a radian is, let's try and figure out how many of them would there be in a whole circle. Well, since the radian, since 1 radian is related to the radius, so whatever radius I have here, if I take that measurement and I cut it out with a piece of string and draw it along here, that would be 1 radian. If I did it again, that would be 2 radians. I did it again and again and again and again. Oh, and it didn't quite work out perfectly all the way around. If I count it, how many radians in a circle? 1, 2, 3, 4, 5, 6 and a bit. Perfect. 6 and a bit. Nice. We're being really accurate right now. We know that it's a bit less than 60. And if it's a bit less than 60, does it make sense that it would be 6 and a bit all the way around? Yeah, okay. Well, what do you think that bit is? What do you think the whole thing is going to be? That's a good question. Well, if I'm measuring things along the outside of my circle, what does that remind you of? Yeah, double pi. 2 pi is approximately 6.28, and that seems very similar. This could be a very good way of 2 pi could be exact, but why is it 2 pi? How is that related to something we've done before?
It's like pi d, the radius is half a diameter.
Radius is half a diameter.
Pi d is equal to 1 circle, therefore.
And what's that called? 1 circle? But what part of the circle are you referring to? The circumference. We know that our circumference formula is pi d or 2 pi r. And that is exactly what your circumference formula is telling you. Every time you have a formula, it's a relationship. Your circumference formula is telling you right here that you have 6 and a bit radiuses all the way around. And so, how many radians are there in a circle? Exactly, there are 2 pi radians in a circle. All right, we've got some information here. So my question for you is as follows. If I make a chart here and on this side I put degrees and this side I put radians, I want you to tell me some values that you know both of, that they're equal to each other. And then I'll give you some extra ones. So give me a statement. Blah, blah, blah degrees is equal to blah, blah, blah radians. What numbers could you tell me? Perfect. 2 pi radians is equal to 360 degrees. Yes? Pi equals 180 degrees. Excellent. Pi over 2 is 90 degrees. Good. So we can start to see that we can find a whole bunch of different ones. So now, if I tell you 45 degrees, you tell me how many radians? Pi over 4. Okay. If I tell you, there we go, pi over 6 radians, you tell me how many degrees? 30? One of the things I want you to notice is that this one is really helpful for figuring things out. How do you go from here to here, from pi to pi over 6? You would have to divide by 6 or multiply by 1/6. Can you see that that also happened here as a way to figure it out? So if I wanted to figure out what 1 degree was, what would I write? Pi over 180. Again, I could take that 1 in that red box. I could divide by 180 to get down to 1 degree. So I could divide by 180 and find out that 1 degree is pi over 180. And if we're doing that, we may as well find out what is 1 radian exactly. What's 1 radian exactly? It's not 1 degree. (180) divided by pi. If you think, how would I get from pi to 1? I would have to divide by pi. So I divide this one by pi as well. 180 divided by pi. Test it out. Take out your calculator. What is 180 divided by pi? I mean, it's a decimal that goes on forever, but approximately it is, if I round to 1 decimal place, 57.3 degrees. That's a little bit more exact than a little bit less than 60. Ooh, neat. What's neat is, sorry, you don't realize that when I teach you math, sometimes in my head, I'm doing other math at the same time. So one of the little math things that I did in my head before was, at this point, when we said 6 and a bit, and we got 2 pi, and someone said it's 6.28, it was like, so that's what a bit is. A bit is 0.28. So I was like, yeah, it's just a little silly thing in my head that I had. So I have a bit as 0.28 in my head, and I'm playing around with it, and nothing interesting happened until here. What happens when you take 60 and you minus, well, instead of 0.28, I minus 2.8? You get 57.2, which is really close. And I was like, ooh, that's kind of cool. Maybe I shouldn't say what happens in my head, especially not on video. Oh, no. Oh, well. So we've got our chart. We've got our degrees. We've got our radians. We've got a way of doing it. If you look at the next page, we've got on the next page, I think this is the page. No, this isn't the page. Is it this page? Is it this page? This, yeah, this one. if you go on the next page where there is an orange box, it tells about radians. In particular, these ones are important because that's what you're going to remember. You're going to remember pi radians is 180 degrees. Or you might know that 360 is 2 pi. And if you know those, you can figure out all the other ones you want to. And that's one of the things that we're going to be doing, is getting used to radians and learning them. Yes?
Like degrees is a little degree symbol. Is there a symbol for radians?
There is no symbol for radians. So yes, with degrees, you always have a degree symbol. And in grade 11, if you forgot the degree symbol, you lost a half a mark. And you thought, oh, everybody knows what I'm talking about. But technically, if you label something as 30 and you forget the degree symbol, it's automatically radians. So anything without a symbol is radians. And so then your answer is quite a bit off, right? Right? If you forget your units when you're saying how tall you are, I'm 5'10", right? If you forget the units and just make other units, I'm 5 miles, 10 yards, right? It's like, wow, that makes a big difference if you mix up your units. So what we're going to do is now we're going to look at our formula that we created this morning, which was arc length. We're going to rewrite it now in degrees off to the side here. So our arc length in degrees, and for whatever reason, we're going to use S for arc length. I guess A got used too much for area. S for arc length, we found out it was whatever angle divided by 360, that was our proportion, times by our circumference. And I talked about how it was nice not to simplify that formula, because if it's this way, you're going to remember it. If we simplify it, you might forget it. We're also going to now create a formula for arc length in radians. So if we're doing our arc length in radians, instead of theta over 360 degrees, we're going to write theta over 2 pi times by our circumference, which is 2 pi r. And I would like to leave that formula like this, and I would leave it like this, but it also makes sense if you simplify it. And if you simplify, do you see how nicely it simplifies? Like the 2 pi and the 2 pi cancel out, and we get theta r, which is a beautifully simple formula. Now, what does that mean? Well, if I have a circle, and it has a radius of 7, and I say, if your angle is 3 radians, what is the arc length? Well, remember that 1 radian is 1 radius along the outside edge. So 3 of them, the arc length would be 21. So you could do it as a proportion, 3 out of 2 pi times the whole circumference, but you could also say that the second formula makes sense from the definition of a radian, is if we know how many radians we have, that's how many radiuses around the outside we would have. And if we know the length of the radius, then we just have to count 7, 14, 21 and figure it out that way. And this formula is on your formula sheet.